Okay, let's look at the check for understanding. So for this question, we're looking at scatter plot of Major League Baseball wins in 2016 along with their payroll. So how much teams get paid, players get paid. So we've got 2 points here we want to label. The points highlighted in red represent LA, which is on the far left. So this is LA. And then this one is Cleveland, on the far right, and then Cleveland is on the far left. So for the first question, they're asking us for the point LA, how is that, for the point LA here, how is that influencing the line? So we want to think about, did we add it above the pattern, below the pattern, to the right, or to the left? We want to think about our simulation a little bit. So here, what we've got is a point that's been added to the right side. And so when we added out in the horizontal direction, that was more of a tilting to our line that affected a number of things. So if I tilt my line down, which the line would probably do here to catch this point, it's definitely going to tilt. That's going to bring this end of the line up when that point is put in and taken out. So when we do the tilting, that's going to affect the slope. And in this case, since it's added below the line and to the right side, it's going to decrease our slope. So our slope's going to go down, but then because of the tilting, that means the other side of the line is coming up. So the y-intercept is increasing. Now, as far as the correlation, we would probably want the number, and would you want to recalculate that or check it with the computer. This still kind of fits the pattern, so I don't know that it would change the R value too much. But in this case, they're not just asking us for the influence. And so since we don't have a way to measure the R value on here, we're just going to stick with slope and y-intercept. Those are the two things we do know. So for part B, Cleveland, we want to talk about what influence does Cleveland, so this point, have on the standard deviation of the residuals in the R squared. So S and R squared. So we just have to think about S is like how the average error that we have every time we make a prediction. So like how close is Cleveland to our blue line? Not very close. And then R squared is basically the amount of wiggle room, between the points and the lines, and how much of that spacing is really okay and how much we can account for. So Cleveland, if we look at Cleveland's probably an outlier because it's got a high residual and it's kind of above the pattern. It's not doing super great. So in this case, definitely, since it's going to affect the strength of the relationship, since it's disconnected, we would say the R squared value, since R, like the strength of the relationship is R and that's being affected here, then when you square that number, that's going to be affected. So Cleveland is a large residual. So R squared is the percent of the space we can account for. So in this case, like, we're not going to be able to account for all of this anymore with this wacky point. So the R squared would go down. And then the amount of error every time we make a prediction, since the line is so far away from the point, the S value is going to go up. We're going to be more wrong on average with this point added in because it's so far away. So we can't account for that space, and in general, it's going to throw the accuracy of the rest of our predictions off because it's so far away. So now for this one, we're going to use the data that's given up here just to plug and chug and get the equation of the line, because in case it comes up, I can say we went over it. Like I said, it doesn't come up a lot. So, okay, so we want to find our numbers. So we've got the mean. Ooh, just kidding. I'm going to make a separate video because I don't want to re-record the first part. So I will go over this in a secondary video.